Alright, this video lesson we're going to 1.3 functions, and again, like a lot of the stuff in chapter 1, this is review. You probably saw this last year in Algebra 2. From your handout for your set of notes, function, you can put in there the definition. Revisiting this function, what that means is for any equation, for every x value that you put in, you only get one y value. It can be exactly, keyword there is exactly one y value. So if you can put in an x value and let's say you get two y values back, then it's not a function. Now to kind of demonstrate what this means, if I use an xy chart, let's say I look at the first example in the blue. Let's say you plug in 1, 2, and 3, and you get back from that 4, 5, and 6. This would represent a function because for every x, you get one y value. For 2, we get 5, and that's it. For 3, we get 6, and that's it. So this is a function. For the green, okay, let's say I put the same numbers in 1, 2, actually let's change it 1, 2, 1, and then I'm going to put in 2, 4, negative 1. This right here is not a function, and here's why. Because we get 1, 2, and we get 1, negative 1. Now this is the same x value, 1, but I really get two different y values. I get 2 and I get negative 1. So this is not a function. So I can only get exactly one y value. Okay, let's go to the next part of your worksheet where there's two equations. Okay, and your directions say which of the equations represents y as a function of x. So it has to satisfy that definition. For every x, there's only one y value. Alright, for this first one, we have x squared plus y equals 1. Now, if you want it in function form, if you hear that a lot, what that means is you want to get y by itself. When you graph anything on the TI Nspire, you have to have it in function form. Y has to be by itself. So if I got y by itself here, I would just subtract x squared. So I'd have y equals negative x squared plus 1. And if you look at that, if you plug in x values, you're only going to get one y value. I mean, you could check it. You could make a little xy chart. I'm going to plug in, let's say, 0, 1, and 2. If you plug in 0, well, that's negative 0 squared 0. 0 plus 1 is 1. If you plug in 1, well, 1 squared is 1, but you still have negative 1 plus 1. That gives you 0. If you plug in 2, 2 squared is 4, but you have a negative. So that's negative 4 plus 1, which gives you negative 3. See how I'm only getting one y value for each of these? So this is a function. So I say, yes, this is a function. Now, since this is a function, I could also write this out. Instead of putting this y, I can replace it with, which is what we're going to talk about next, function notation, with f of x. F of x is the same as y. F of x equals negative x squared plus 1, because I proved that that's a function. Okay, let's look at the next one, number 2. Okay, for this equation, we have negative x plus y squared equals 1. Now I need to get it in function form to see if it satisfies the equation. So this one I want to, let's see here, add x to each side. So we're going to have x plus 1. Then I take the square root of both sides. And now remember, you take the square root of y squared, that's y. But when you take the square root of the right side, you get plus or minus. Don't forget that. You get plus or minus the square root of x plus 1. Now that kind of gives it away, this plus or minus. This means when you plug in x values, you're going to get two answers. So this is not going to be a function. If you can't see that, you can do the same thing, make an xy chart. Let's say I plug in 0. If I plug in 0 to this, I have, what is this, plus or minus the square root of 0 plus 1. Well, then this is just plus or minus the square root of 1, which equals plus or minus 1. So there it is, I get two answers. For the one x value of 0, I get two different y values, positive 1 and negative 1. So no, this is not a function. Okay, let's get into, kind of back to the first one, when we did function notation. Okay, that's in your notes, function notation. The biggest thing to remember with function notation, and whenever you see me just write fn, I mean function, is, as we said before, f of x equals y. Now, if I were to work with the function that we did get for the first problem, when we wrote that out, that was function of x equals negative x squared plus 1. And then let's say we wanted to evaluate the function of 1. Well, I just plug 1 in for x squared. So I'm going to have negative. Now remember, there's always like parentheses around this whenever you're plugging it in. It's assumed to be, so it's negative, and then it's 1 squared plus 1. 1 squared is 1, but then you have the negative. Negative 1 plus 1 is 0. So that's your answer. Okay, let's do the next one, number 4. Let's go function of 3. So I'm going to keep the negative on the outside, then I have parentheses, then I have 3, and then I square it, plus 1. So 3 squared is 9, but I drop the negative. Negative 9 plus 1, this gives me negative 8. So this really is just like saying, for number 3, it's just like saying evaluate the function when x equals 1. Number 4 is just like saying evaluate the function when x equals 3. But it's just in a different notation. Let's make it more abstract. Let's use this same one. Okay, I'm going to erase these two. But now I'm going to put in the function of x plus 1. Okay, which is what you have on your handout. Alright, so when I do this, so we'll say this is number 5, let's evaluate the function of x plus 1. What this means is, for all the x's, I'm just going to plug in x plus 1. So I'm going to have negative of, and then instead of x squared, it's x plus 1 quantity squared. Very important that you have that in parentheses. So this whole thing, I'm plugging into this x. And then when you FOIL this out, this is going to give you 3 terms. You're going to get x squared. A lot of people forget this, the plus 2x. They just get x squared plus 1. The 2x is where we double this product. X times 1 is 1x. Double it, you get 2x. And then when you square this one, you have plus 1. A lot of people just put x squared plus 1. Then I drop this plus 1 down. Then I have to distribute this negative to everything here for this quadratic trinomial. So you distribute that negative, it's negative x squared minus 2x minus 1. And then I bring this down, plus 1. It's going to wind up canceling out with this, and you're going to have that negative x squared minus 2x. And then this, you might be thinking, oh, well, I can take an x out. Just leave it like this. That's really not going to make it any simpler for you. You're not solving for x. When you plug in values, like an expression for x, you're still going to have variables. Just simplify it all the way. So your answer there is at negative x squared minus 2x. Okay, let's look at another example. One last one. Okay, I'm going to give you a different function. Let's go g of x. This is going to equal negative x squared plus 4x plus 1. And then for this, we want to find g of x plus 2. So it's pretty much the same as the last. So when I find this, g of x plus 2, I'm plugging x plus 2 into this x and into that x there that's multiplied by 4. So when we do this, we're going to have, let's see here, negative on the outside. That x is replaced with x plus 2 quantity squared. And then plus 4 times x plus 2. And then I'm going to just bring down this one, so it's plus 1. So you're just a matter of foiling and simplifying, combining like terms. That's pretty much what this problem's about. Okay, I'll leave the negative on the outside. When you square that x plus 2, you get x squared. Now the product of x and 2 is 2x, so you double it and you get 4x. Remember, that's just adding your outer and inner terms together. And then this 2 squared gives you plus 4. Okay, then when I distribute this 4, we get plus 4x plus 8. And then I just bring down this last one, plus 1. Okay, then to get rid of this parentheses, I distribute this negative here to that quadratic trinomial. So we get negative x squared minus 4x minus 4. I bring everything else down, plus 4x plus 8 plus 1. Okay, when I combine this, let's see here, there's nothing going to be with x squared. So that's just negative x squared. So I'm done with this. Okay, I look at the x's. I have negative 4x plus 4x. Well, they're opposites. They go away. They cancel out. And then when I look at the numbers, negative 4 plus 8 is 4, and then plus 1 is 5. So we get negative x squared plus 5. And that's it. That's all you can do to it. You can't combine any of these terms. They're unlike, and you're not solving for x. So that's pretty much it. That is the first half of 1.3 on functions, basically using the definition to figure out if an equation is a function, and using function notation where f of x can replace y.